it's not a holiday. Next week, wait, let me check my calendar. Next week, Monday is President's Day.
Yes, yes.
But
Yes.
but because it's not a holiday for me because I'm a contractor, so I don't really have holidays.
Oh, contractors doesn't have a President Day holiday. That's sad.
Well, we have what we call floats, but I'm gonna save my vacation time. I'm just gonna work through. We want to get the major federal holidays.
Cool. Okay, I think we can start off with this because others can at least get the recording. Cool. Sami, all good, right? You don't have any questions or doubts? You understood everything in the last session?
Yes, I do have some problem like accessing S3 buckets through CLI. So is there any permission that we need to add? Like, should we keep anything public to access, or else is it like
Not necessarily.
not necessarily, right? So yeah, I just want to try by myself. I want to Google and I want to get some solution. If I could not do that, I would ask you on Monday.
You can ask me tomorrow also. So
Sure.
probably the points that you can tweak in for is a bucket policy. If you have a restriction like deny in your bucket policy, or probably if you are trying to access a S3 bucket using a Lambda or an EC2 or any other resource, that resource should have a role. That role should have a policy which has S3 permission. That you need to add.
Okay, I'll check that. Yeah.
Okay. Other than that, everything's okay, right?
Yes.
Am I using your AWS account or someone else's?
That's my AWS account.
Oh, okay. Sorry and thank you. If I leave any resources, please take it over. I will not leave, but just saying. If it is serverless, I'll leave. That's okay. Got that right?
Yes.
So today we will start with a new Python concept. It's called as TriException logic. Okay. So all these days when it comes to Python, we spoke about how to write the code to achieve something, right? So to build a logic to get an output, an expected output, and you always have an expected output. So you expect something and then you start the coding, right? So there are various kinds of development techniques, but essentially you will follow something called as TDD. TDD is nothing but test-driven development. As a data engineer, as an application developer, as a data scientist, as a DevOps engineer, it doesn't matter what you are doing. Test-driven development, if you are developing something, test-driven development is always a direction provider. Okay. So what happens is when a developer gets a task to implement something, then he develops something, right? Let's say the task takes around a month. The time he starts developing, he understands the task in one way. The more he works, the more there will be the findings about the task, and the vision and the direction over the development will change for sure. It could be the change in client requirement. It could be about the possibilities of happening. You could be wrong about assuming the things that this is possible with this, and then it is actually not possible, or there are any issues, right? So we will roll back, and then there will be a hassle around. Okay, so that 1 month task might go and stretch for around 2 months. So the point is, in order to minimize the randomness and predictability, okay, so what we can do is we implement something called as test-driven development. you will have to say this. Okay. The first point is we already saw how the file events are getting triggered via Lambda, so that you will be landing your source files into S3 first, which will in turn invoke the Lambda out of the blue as soon as the source files are getting uploaded, right? So how the source files are getting uploaded? There will be a pre-signed URL that you will give to the source systems. Okay, pre-signed URL. This URL is available in two flavors: GET and POST requests. Okay, so GET is if you want to share any data from or any file from S3 bucket to your clients for them to access. That is GET request for them. If they want to post the source file to this S3 bucket, that will be a POST request. And you will have a timeout for this URL. It's one of the very secure way of accessing or giving access to your source bucket, to your S3 bucket, to your clients or whatever, right? So you can put a time limit of 120 seconds. You can put a time limit of 5 minutes, 30 minutes, anything, right? So now, if let's say you put a time limit of half an hour and then share the link with them, a random link, pre-signed URL that you generate using Boto3. One good point here is you cannot generate or create pre-signed URL using console. You'll have to use Boto3 or AWS CLI. Okay, so only for that 30 minutes, let's say if you have a 30-minute timeout, time limit. So only for that 30 minutes, that link will be active. After that, it will be totally useless. Okay, so that you're actually restricting the time window of that link to access these files. Having said that, once the file is into your system, you'll be processing the file using lambdas. Okay, so for very short files, you will be doing the way we did yesterday. Okay, but there's a problem there. So if you go to the Lambda limitations, Lambda cannot run more than 5 minutes. That's a limitation that is set on Lambda. Okay, we'll discuss about the limitations for a few minutes, and then we will enter into test-driven development. Okay? So, and again, we will not talk more on test-driven development today because we have something else. That test-driven development is a topic which is to be discussed before we discuss this TriException logic. There is some link between these two. So if you see this Lambda, there is something called as time limit. Timeout is 3 seconds. All right. So if you execute your code, if the code is running for more than 3 seconds, Lambda will fail with timeout error. And you can only run the memory up to 128 MB. You cannot process 1 GB file here, or the file that is more than 128 MB here. Okay, that is the limitation you set. But if you edit it, you can only go over for 10,240 MB. Okay, and then this will be only, let's say 10 minutes if I give, and then save it. Just a second. It should not save because 300 seconds is its limitation. I'm out of AWS Lambda. Just a second, I was curious. Oh, sorry, my bad. It goes till 15 minutes, okay? So it cannot be increased more than 15 minutes, okay? Maximum timeout is 15 minutes. So that was the limitation on AWS Lambda, which you cannot do anything about it. So resource limitation and timeout limitation are one big constraints of Lambda. So if you are processing about the big data, what you can do is you have to fetch an alternative. Okay. So what you will do is same process. even if it is 1 GB file, an event will be triggered and that Lambda will be invoked. Inside the code, you will know that there is a file that is processed, right? What you will do here, you will invoke a glue job from this Lambda. Okay. So glue is another resource that is for processing. It's exactly same like Lambda, but it is way more than Lambda for transformations. Okay. It has Apache PySpark installed automatically. So it acts as a serverless ETL. You can create a glue job just like Lambda, give all the properties that you wish to configure, and then run the environment as Spark, PySpark, normal Python streaming, like that. Okay. So we can go with Python 3 Spark is PySpark. Okay. Scala is another version of Spark. Okay. Then there are the other versions. So this is just like the script file. For Lambda, you can directly write the code there, right? So, and you can also upload the code in Lambda actions, and then upload a zip file. This will come here if it is less than 5 MB or something. If it is more than 5 MB, you will not be able to see the code here. Okay, that is another problem with Lambda. So now we'll upload your script in the similar way. It will come there in the console and you can edit it. So there are more advanced options and use cases of Glue. We'll talk about them when we are actually drilling down more on Glue. But the point is our story, the sequel of our story is we have AWS Blue that will transform and process the jobs. There will be many machine learning data pipelines also that were integrated with AWS Blue because it has PySpark integration with it. PySpark has a library called emlib. It has all managed machine learning and deep learning implementations. Okay, so having said that, okay, our next step is if it is huge data where your Lambda fails due to its limitations on resources and timeouts, you will process using Glue and then dump the data into Redshift. What will happen there? The story of our stage tables, intermediate tables, and then fact tables, dimension tables, the data model, blah, 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 right? That gets activated. That is your whole story as a data engineer. Got it, right? So I hope the dots are getting connected right now at least. And then how do you push the code into your environment? This is your environment. Is another big question. Okay. So we push the code using GitHub. We connect the GitHub to code pipeline. Code pipeline will be connecting to a build tool, which is called as code build. So we will talk about that in detail too. But then for now, we were rolling our story back, our concept back to test-driven development. What is this test-driven development? We write test cases, unit test cases first, and then start the development. I repeat, we write test cases and start development according to the test cases. It means your end goal now is already set. Your end goal is to successfully, to make sure your test cases are succeeded. Okay. So when that is done, the requirement will have a proper direction. Having said that, so whenever there is something that breaks the code, so till now we discussed about how to write the logic itself, and then we were telling about how to deal with exceptional scenarios. That's where unit test cases also comes into picture. So a unit test case is a situation where we test the boundaries. Okay. For example, I declare A is equal to B is equal to 4. I want to print A by B. This is the code I want to push to production. Do I sense anything wrong here? No, absolutely fine, right? We can actually push the code to production. But if we are following test-driven development, there will be a test case assuming the boundary conditions. If I assume boundary condition of b to be 0, I will get an error because it's 1 by 0, 0 division error, right? This is a very simple example where your code fails. Okay. Now, the point is, if at all you expect any boundary conditions here, what you need to do, right? So option 1, fail the program. It's a very bad choice. You never do that. At any condition in production, failure is not acceptable. The kind of an escalation depending on the sensitivity of the setup. An example that I can give you is, if Facebook's or Amazon's login page stopped working for a minute. Very recently we saw Google going down, right? It's a huge negative impact on the developers of Google. Being a mighty giant, having its own cloud setup, which is a competitor for AWS and Azure. You cannot expect that giant enterprise to go down, not for a minute. It's around for several minutes, right? So we cannot expect any failures in the production. That is the bottom line. That's why we keep exceptions everywhere. So what these exceptions do, instead of keeping it here, if you expect the code to give exception, you will put that code inside the try block. Okay, and then you execute it. Now when you put it, right, what happened here? You are raising an exception. Sorry. Okay. What happened here? I'll again raise an exception. See the traceback. Okay. This is the entire thing, garbage thing, right? Instead, we take only the description of the exception. The exception name is 0 division error. The description is here, right? So let's comment on the rise part, then start print E. Okay. So the program did not fail here. It showed an exception. That's it. So now, what I can do is I can actually hold or catch. It's a generic exception. Okay. Whatever the exception you're getting, I can actually catch hold of a specific exception also. What is generic and specific exception? Actually, there are many such exceptions like this: 0 division error, keyword error, keypad error, and then file not found error, object not declared error. There are many errors, name error. For example, if I give C and execute, C is not defined as the exception. All right. So now I can easily catch this by its name. This is name error exception, right? So I can say except space name error, then print we got a name error. Okay. Instead of that, you'll get this. Okay. So if you use raise here, you will get the traceback too. Got that right? That's just a functionality that is present in Python to raise certain exceptions. Okay. So we are nearing to the end of our sessions. So our story is getting a bit strengthened or maybe a bit deeper. We have successfully finished our first step of our data engineering setup that we have in our AWS cloud, right? So we also know about what we do after we enter Redshift DB, about stage table, intermediate table, fact table story. Upon the fact tables, there will be views. Upon the views, you will have reporting. Reporting is done using Tableau. All right. So having said that, it's definitely important to be more cautious when compared to the other sessions, because we are actually going in a typical 5x velocity, I can say, compared to our initial velocity. Okay. So here we're talking about TriException block as a whole skeleton. Okay. So now let us discuss about the possibilities of try. Okay. I'm just giving this. Okay. So what happened here? Line number 492, we got an exception. After that, there is a print statement in line number 493 which did not execute at all, which means if there is an exception, the lines of code after that exception will not be executed. It will directly go to the exception block. That's why you got that print statement. Okay. Okay. If I execute this, no, is it going to the else block? Did it go to the else block? It went, right?
No.
Right? Okay. We did not go to the else block. Okay. It went to a finally block, but it did not go to the else block. Don't know what's happening. Okay. Let's correct this exception, for example. Now. Okay. We'll go with A itself. What happened here? Since there is no exception, after exception is also printed. Makes sense. There is no exception, right? So there is no we got name error or print E, whatever. Okay. But we got the print statement from else also, which means, and we also got the finally block. Okay. So when you debug this analysis, so the properties of this try exception block is like this. Whenever there is at least one exception that you get in your code, your else block will not get executed. Whenever you have a finally block, it does not matter if you have an exception or not, finally will always get executed. Okay. So what is one of the general use case of this finally block is? As an example, you have a file, you opened it and you're writing some content into the file and you got an exception. The file is in open mode. You did not close that, right? So the next time, if you are restarting the program, you will be stuck with a different error saying that the file is already opened. It cannot be reopened because it is already opened, right? In such cases, in finally block, you need to write your cleanup process. If you have already connected to the database, right? And some exception occurred, you need to close the connection to the database. Otherwise, it is consuming the resources. Even with the file operations, okay, normal write mode will still be open. You can actually get access by other programs also, but it consumes a lot of resources as long as the file is open, right? So all the cleanup process of closing the files, closing the database connections will be done inside finally block. So that is how you implemented the try exception block, but you can also implement something called as manual exceptions. Okay, so the manual exceptions are the customized exceptions. So for example, if you want to get an exception, we are creating an exception, right? But if A is greater than 2, I want an exception. Okay. Now what will happen? You entered into name error. So this is also a customized exception because it has a name called name error. Don't you think it's a built-in thing called name error? Because if you change this name error to name error 1, it does not exist. You can actually see that the color change, right? So it means it's just a built-in exception, and we are making use of it, and we are raising it at a condition. So instead of that, we can use exception class. So that would look like there is an object called exception class. So this is the object we need to use. Yeah. Okay. Custom exe, let's say, can actually raise this guy. Okay. So what I can say is except this guy, something like this. Okay. So what did you do? You're making use of these manual exceptions to create your own exceptions. So if at all there is a business case where you have a file with 10 columns, your second column cannot get the data that is greater than 2. That is a business condition, let's say, in your data. You can hold your custom exceptions like this. All right.
What is the purpose of the raise statement?
So what did you do here? You explicitly pushed that logic to accept block. Don't you think so?
Oh, okay.
Usual behavior is if you do not use raise, it will not go into exception block at all.
I see. Okay, thank you.
And again, one more thing. If you are raising a custom exception, it will go to that exception. But if you have a raise keyword inside your exception, it means you are interested in traceback. So traceback is given in detail when you use raise object. Okay, cool. So that's about that. And without further delay, I can close this stuff today. And then I can actually fasten up the process with PPTs. Now you can observe how beautiful or how easy to follow up these PPTs, maybe. We are no more at the basic level where we need line by line of code to be executed. If at all needed, we will definitely do that. If you see this, these are all the flavors of string formatting that we discussed on the other day. With the placeholders, with f strings, etc., etc. When you can use class objects to declare the string formatting, but we are not at a position to understand this right now because we will do that. We will discuss about the classes also. Then we can revisit it. So I want to discuss today about the file operations. Files in Python can be opened in various ways. Open is the keyword that is a basic starting keyword or functionality that can be used to open files, normally text files. Okay. So if you say open off and the file name, it means that file should be existing in the same location where you are running the script. Wherever your Python script is there, in the same location, the file should exist. You can open the file in all these following modes: read mode, write mode, read plus write mode, append mode. So there is a difference between write mode and append mode. So if you open a file in write mode, it will overwrite the existing contents. It will replace. But if you try to open the file in append mode, it will not replace, but it will append the content to the old content. F.name will give you the file name. F.mode will give you the mode of the file operation, W, R, RB, WB, like that. RB and WB are read binary, write binary. So it is a universal format, binary format. You can even deal with pictures if you are using binary mode. Okay, code. Then when you open the file using open command, as we discussed earlier, we need to close it. Otherwise, resources will be wasted. But in Python, there is a concept called context manager. Context manager comes up with keyword. If you are doing something with keyword, it is called as context manager in Python. What it will do is you don't have to close the file if you are using with command. The context manager itself will close the file. That is some cleanup process that is inbuilt inside the context manager. It's just a matter of changing syntax, a bit of it, but the functionality remains the same. One add-on is you don't have to look up the cleanup process. So let's say you open a file in read mode. These are the various ways you can read the contents in the file. If you say file.read, the object that you gave here, okay, dot read, it will read all the lines at a time in one go. If you give 500 lines of file, you will get all the 500 lines in one go. But if you use read lines attribute, you'll get a list of lines where each element is a list element. I mean, each line is list element. Okay. So when you read the lines, every new line will come as /n. Okay. And read line is another attribute. How do I know all this? Read lines, read line. You can just say dir of f. Okay. You'll find all these attributes. Now read line, what it will do? It will read, it's an iterator. Okay. It means when you do this read line, you'll get one sentence. If you copy paste the same below, you'll get a second sentence. Okay. So for example, I can demonstrate this thing to you. Because it might be hard to visualize. All going good or something stuck?
Yeah, good.
Cool. I don't see a txt file. Okay, something here is there, right? So we'll use that requirement. Are you clear? Okay. Out.txt is there. It also has some content. Let's use out.txt. Then I'll use pyd, no, file1.py, let's say. I'll say I'll just declare something like with open of out.txt. I'm not giving the relative path because I know that the file is in the same location. I'm not giving the mode here because read mode is optional. If you do not give any mode, it will be by default read mode. You can declare anything here. It will be the file object. Okay. So print file underscore obj dot read line. Okay, so what we did here is we just declared f dot content as an object. Okay, and then we are doing the read line thing. But let's do this for now. Right, we got only one line. Now I'm going to copy paste it 4 times. You got 4 lines, right? So it's an iterator. It's a concept in Python which iterates over each and every element possible. All right. So we'll talk about these iterators and generators concepts going further in Python. You will have to implement a generator in multiple ways because there was much expected. These decorators, generators, the comprehensions, lambda objects, and oops concepts. These are the top contenders that can be asked in the interviews. Okay. So having said that, we are already entering into the complicated concepts of Python. So I'll stop it today here at Python. We'll discuss something a bit on AWS. So here, if you want to modify this code, let's say, what modifications you do to this code? We're discussing about this code, right, yesterday? Not logically, if you want to add something else also. What can be done here? What this code is doing actually? Did you recognize this guy anywhere, anytime? Have you seen him?
Is getting the keys.
From where?
The S3 bucket.
No, from the event, right? Remember, you gave an event here.
Oh,
You gave a
yeah.
trigger, right? So now, as I told you, the functional aspect is one part, but making sure the code is not breaking is another part. So can we add TriException block here? Right? So we can simply say except exception as E and then print E. Nothing will happen. There will not be any change. But in future, if you get an exception, it will be helpful. Right? Oh, sorry, execution details are closed. Sorry, I did not deploy the changes. So it should get executed. I don't know why. Yeah, right. For now, it is succeeded. Let us put a dumb mistake here. Right? And I test it. It is a syntax error. It's not matched. Right? Now, let's put a logical thing. Okay? Where this key is not existing, maybe. Which is not a syntax error, right? See here. None type object has no attribute get, but it is succeeded. If I would have kept a raise command, like we did in the local, or you remove the code from the TriException block, right? You'll get the entire trace back. In Lambda, it is not. It is a container, managed container maybe. But if I remove this, okay, and then save the code, and then test it, you'll get the entire trace back, right? So that is what I'm talking about. So to take care of all these issues, Okay. So you will be having a generic exception log that you will carry forward in your logics. First thing you learned is about wrapping the code as much as you can inside Python functions. Second thing is about having exceptions so that your code will not break any longer. And the third thing is about today. We'll talk about today. The limitations on the Lambda. It has 15-minute runtime and 128 MB resource limitation. Cool. So we also have an integration with API Gateway and DynamoDB. Okay. So DynamoDB is a NoSQL database. What does it has to do here? When we don't need to build a data model, we can use NoSQL database. So for example, you're getting files in an awkward way. One file is having 10 columns, one file is having 2 columns, one file is having 3 columns, like that. Okay. So ideally speaking, the data should be consistent to be fed into the relational database. Every file should have same columns, or weirdly, you're having one file. That file has multiple records. Each record has different columns. Right. In such cases, you still have to load. You cannot load into relational database like PostgreSQL, Teradata, etc. Right. Even for Redshift, it's a columnar database, and it should need the consistency of columns inside its files. Okay. Otherwise, you cannot load. So for such cases, to deal with that random data, you'll be using NoSQL database. So we will talk more on the limitations on NoSQL database going further, but I would like to give you a task where dump the S3 file data into DynamoDB. Okay, using Lambda. Do you know what a DynamoDB is, by the way? No, right? Explore. It's not like a traditional database where you create a cluster, launch an instance. It's not like that. It's a complete serverless resource. You go to the tables, you create the table. That's it. Okay. No, there's already a table here. I did not create it because this is not my account again. So you can create a table, table name, and the partition key, sort key. If you remember, we did not discuss about Redshift. It has a similar type of hierarchy where we have distribution key and then the sort key. Okay. So like that. That being a columnar database and just being a NoSQL database, it has a primary partition key and a sort key. Sort key is completely optional. Primary key is primary partition key is something that you need to declare. It's like at least one column should be there in every record. Is the minimum requirement. Nothing more, nothing less. Okay, that column should be at least consistent. All right. So you can declare your dummy things and then try to load the file data, any dummy data from S3 to Dynamo using Lambda. Again, how will you do that? DynamoDB auto3. Right? When you go here, there is an operation for the client again. You come down, we'll say put item where you will dump the records. Put item is to insert. It creates a new item. Each record in DynamoDB table is called as an item. Okay. So play around with that. If you do not have a way to proceed further, or if you have a blocker, we can discuss. Okay. I want you guys to come up with some effort so that you will definitely get some doubts, and then it will definitely be a good discussion. So having said that, I'd like to stop it right here today. Any questions for me? All good?
Yeah. Can we get the copy of this to look over for the weekend?
Copy of what? The recording?
Yeah, the
please.
video.
Yeah, I also missed the first 20 minutes. Sorry about that. So.
Yeah, I will try to share it today itself.